In this video, we will discuss the trigonometric ratios. They will play a major role in all the math we do in this course. The first triangle is a right-angled triangle. It has side lengths of 3, 4, and 5. The second triangle is a right-angled triangle with side lengths of 6, 8, and 10. We immediately notice an interesting relationship between these triangles. Their side lengths are proportional. The side lengths of the triangle at right are all double the corresponding side lengths of the triangle at left. We can simplify the ratio of the sides as 3 to 4 to 5. Whenever two triangles have their sides in proportion like this, we say they are similar. And we can draw many triangles that are similar to the first one. In fact, here's another one. Its sides are smaller than the original, but the same ratio is maintained. Just looking at the triangle, we notice something interesting. They all look like the same triangle, just bigger or smaller versions, zoomed in or zoomed out. They're all proportionate. What do they have in common? The sizes of their angles. In fact, if you used a protractor to measure all their angles, you would see the smallest angle is about 37 degrees in all of them, and the larger angle is about 53 degrees in all of them. We can generalize this observation. If two triangles are similar, that is, if their sides are proportionate, their angles must be equal. Once again, if the sides are proportionate, the angles are equal. So if you have a right triangle where the ratio of the sides is 3:4:5, any right triangle with that ratio, it must contain a 37-degree angle and it must contain a 53-degree angle in addition to the 90-degree angle. Now, let's take that statement and turn it on its head. If you know that the angles in a triangle are 37, 53, and 90 degrees, then the sides must have the proportion 3:4:5. More generally, this statement says, this reverse statement, if the angles in two triangles are equal, the sides must be proportional. This sentence should also make sense because the presence of those angles forces that proportion of the sides. So you would know that a triangle with these angles must be a bigger or smaller version of the one that you see before you. It must be similar to these. You can't tell how big the triangle will be just by knowing the angles. That is, you can't tell how long the sides will be, but you know they must be in the proportion 3:4:5. Let's formalize this. Consider the 37-degree angle. We can describe the sides on the basis of their relative location to that angle. The side opposite it has a length of 3. The side adjacent has a length of 4. And the hypotenuse has a length of 5. So we could say if a right triangle has a 37-degree angle, the ratio of the opposite side to the hypotenuse must be 3/5, which is 0.6. More generally, if a right triangle has a 37-degree angle, the length of the opposite side divided by the length of the hypotenuse must be 0.6. We call the quotient of the opposite side and the hypotenuse the sine ratio. And so we can say the sine of 37 degrees is 3/5 or 0.6. Similarly, we can talk about the ratio of the adjacent side to the hypotenuse. In this case, that's 0.8. This ratio is called the cosine, and we can say the cosine of 37 degrees is 4/5 or 0.8. Finally, we can look at the ratio of the opposite side to the adjacent side. This is called the tangent ratio, and the tangent of 37 degrees is 3 over 4, or 0.75. In this class, we will mostly use our calculators to solve for the different trigonometric ratios. To do this, you first have to make sure your calculator is in degree mode. To find the sine of 37 degrees on the TI-83 Plus, you would type sine 37 and press enter. It might be different on your calculator, but either way, you should get 0.6. Sometimes you need to do the reverse operation. That is, knowing the ratio of the sides, find the angle that the triangle must contain. This operation, which does a sine in reverse, is called the arc sine, and is often symbolized as shown below. There are two different symbols. And yes, they can be a bit confusing, but both these symbols mean performing a sine backwards to find the angle. So, for example, you would say the arc sine of 0.6 is 37 degrees. On the TI-83 Plus, you would type second sine to get arc sine and then enter the ratio. And you press enter and that will tell you the angle. And there are corresponding inverse trigonometric ratios for the cosine and tangent functions as well. This has been a quick explanation of trigonometric ratios. We will use this in the next video when we discuss vectors.